When we drink a protein shake, the journey of its nutrients begins immediately. As the liquid enters the mouth and travels down the esophagus, the body is already preparing for digestion. Once it reaches the stomach, the protein shake mixes with gastric acid and digestive enzymes, especially pepsin, which begins breaking long protein strands into smaller fragments called peptides. Inside the stomach's muscular walls, waves of peristalsis continue this breakdown process. The shake's proteins, along with carbohydrates or fats it may contain, are gradually released into the small intestine where most nutrient absorption occurs. As the mixture enters the small intestine, it encounters enzymes from the pancreas and bile from the liver. These powerful digestive fluids complete the breakdown of proteins into amino acids, the basic building blocks the body uses to repair tissues, support immune function, and promote healthy enzyme and hormone production. The interior of the small intestine is covered with millions of villi and microvilli, tiny finger-like structures that dramatically increase surface area. Amino acids pass through the absorptive cells of the villi and enter the bloodstream, where they begin circulating to organs and tissues throughout the body.
As amino acids reach the muscles, they contribute to protein synthesis, an ongoing process where muscle fibers repair and rebuild after daily activity or exercise. This is why protein shakes are commonly used after workouts. They provide a convenient source of readily digestible protein that the body can use during recovery. The brain also benefits from adequate protein intake. Certain amino acids serve as precursors for neurotransmitters, chemical messengers that influence mood, focus, and cognitive function. While a protein shake is not a direct brain booster, maintaining proper protein intake helps support normal neurological processes. In the gut, protein contributes to a balanced microbiome when consumed in appropriate amounts. Beneficial bacteria use amino acids for growth and maintenance, helping support a resilient intestinal environment. However, responses to protein shakes can vary. Some people may experience mild stomach concern, particularly if the shake is consumed too quickly or contains ingredients they cannot tolerate, such as lactose or certain artificial sweeteners. Allergic reactions can occur in individuals sensitive to specific protein sources, like dairy, soy, or nuts. Large amounts of added sugars may contribute to temporary increases in blood glucose levels. And in people with digestive sensitivities, certain formulations may lead to fatigue or sluggishness as the body works harder to process them. When used appropriately, protein shakes can be a convenient way to support daily protein needs, complementing, not replacing, a balanced and nutrient-rich diet. Their effects depend on the individual, their health status, and the overall quality of their nutrition and lifestyle.